list, you can add an element in a list, and also you can delete an element in a list. What I didn't tell you now in details, I was supposed also to tell you now the difference, the characteristics of a list. One characteristic of a list, it is mutable. What I've just said. The second characteristic of a list, it is ordered. The second characteristic of a list, it is ordered. And then the third characteristic of a list, it has duplicates. It has duplicates. A list has got duplicates. What does a programmer use to know that this is a list, a tuple, a set, or a dictionary? A list is represented in Python programming by a squared bracket. A list is represented by a squared bracket. When you are writing a list, you have to represent it using a square bracket. And I remember last week, I showed you a different example that shows that a list is mutable. And under mutability of a list, we saw we saw some examples, uh, such as where you can replace element, and this is a characteristic that makes now a list to be mutable. I showed you how you can replace different elements. For example, if I want to replace an element in index 0, which is 2, with 5, this is how I showed you how to replace. Then the second thing, which I didn't show you last week, but now I'll pass through it in brief. Um, in a list, you can add elements in a list. You can add element in a list. And there is two ways. In fact, there are more than two ways of which you can use to add element in a list. The first way is where you can see here I've written my list and I've given it number 2, -3, 0, 4, and -1. In this list, I want to add one element, and the element which I want to add in this case is 4. I will use the addition sign. I will use the addition sign, which we normally use in mathematics. Now, I'll say now in this list, I want to add 4. I write the name of my list here is LST. I will put plus sign. That means I'm going to add. Then I say is equals to 4. And this 4, it means I'm going to add to the list containing elements 2, -3, 0, 4, and -1. And it will add. And when you use this method, an element which is added automatically goes to the far, what can I say? It goes to the extreme right, or it is added as the last element within the list. It is automatically added as the last element within the list. The second way of which you can use to add an element in a list is for you to use an inbuilt append function. Is for you to use an inbuilt append function. When you use an inbuilt append function, it adds the new element to the end of the list. It also adds the new element to the end of the list. So you can choose which one is easier for you when you want to add an element to the end of the list. You can either use this first method where I've taught you that you write LST plus is equals to 4. It means an element 4 is going to be added at the end of this list. If you see that one is not easy for you, but I encourage, if you want to add an element at the end of the list, always use append function. So when you use append function, it will add this 4 at the end of this list. You see now I've written the list, which is 2, -3, 0, and -1. Then I want to add 4 at the end of this list. So I'll say LST dot append. Then what do I want to append? Here I want to append 4. So this element 4 it will added automatically at the end of that list. What if now and now you have to note that it modifies the list. When you add an element to a list, it modifies a list. What does it mean by modifying a list? It changes the length of this list, because at first, how do you know now it has changed the length? At first, this list you can see add 5 elements, but when now you add an element 4, it will have 6 elements. This means it modifies the list. How does it modifies the list? It changes its length. Now, in the second case, to show mutability of a list, you can also use insert function to add an element in a list. Now, when you use insert function, it is different from append function, because when you are using append function, it automatically adds an element at the end of a list. But when you use insert function, a programmer can specify the index which he or she wants an element to be added. For example, in this case, I have my list. Then I want to add an element. In this case, it will not add it automatically at the end of that list. It is the programmer who now specifies where the index where that element should be added. For example, now in this list, you see now I want to add an element 4. So in this one, I've written lst.insert. When you use insert, this is where now you will specify. I want this element 4 to be added in the 4th index. I wanted it to be added in the 4th index. Now, when I will run, you will see this 4 has been added in the 4th index. This is the 0 index, 1, 2, 3, 4. If you want it to be added at the 0 index, you just put there 0. And when you will run, you see 4 has been added at the 0 index. So the difference between append function and insert function, when you use insert function, you specify it specifies a programmer has to specify the index where you want an element to be added. But when you use append function, it just adds an element automatically at the end. So that is the second characteristics to show mutability. The first one I taught you last week. This is where now you can replace an element in a list. The second one, that is where now you can add an element in a list. And in adding an element in a list, you can either use append or insert. When you use append, it will add an element automatically at the end of the list. When you use insert, a programmer has to specify. Then now the third characteristic that show that a list is immutable is mutable. It allows a programmer to remove elements from a list. And this is where now it allows a programmer, there are different ways which you can remove an element, you can delete an element from a list. The first one is where you use an input remove function. The second one is where you use the pop function. And the third one is where you use the clear function. And you are going to pass through each and every function which I've mentioned in detail. When you want to remove one element, you only want to remove one element from a list. That is where you will use remove function. For example, I have my list here. This list has got 2, -3, 0, 4, then -1 and 4. I want to remove -1 from this list. So I will use the remove function. I'll say lst.remove. Then I specify the element which I want it to be removed. And when I will run, you will see here the output. The output doesn't have -1. What if now I want to remove 4? I want to remove 4. I'll just do like this, and I remove this 4. And when I run, you will realize now the output will not have 4. So when you want to remove only one element from the list, you will use the remove function. What if when you want only to remove the last element from the list? When you want the program to automatically remove the last element from the list, this is where you use the pop function. This is where you use the pop function. So when, for example, I have my list here containing these elements, and I want to remove only the last element, which is 4. I'll say lst.pop. So when I'll run, you will see now in this output, it doesn't have 4. In the third now method, this is where I want now to remove all the elements in a list. I want to remove all the elements in a list, not a set, in a list. I will use the clear function. You see, I have my list here. Then I want to remove all the elements. I will say lst.clear. So when I'll say lst.clear and I run this code, you see it has given me a null list or an empty list. So when you want to remove everything, you use clear. What if now you want to delete an element in a specified indices? You want to delete an element in a specified indices. You see, I have got my list, and now uh, below there we learn about slicing in details, and we discussed a little bit last week. I want to remove now. I want to delete uh, element from my list starting from index 1. It means it will start now from -3 all the way. When you see it has been written 1, then that full colon, it means it will start from -1 all the way. So when I run, you see it has deleted everything. So when now you want to delete an element in a specified index or indices, you will use the delete function. What if I wanted to delete maybe up to maybe I wanted to delete up to index 3? It means it will delete all the elements starting from index 0, 1, 2, 3, and it gives you the remaining. So when I run, you will see it will delete all the elements from index 0, 1, and from index 0, 1, and 2. They are not 3. It will delete all the elements from 0, 1, and 2, and it will give you the remaining. So this shows that a list is mutable, because you have seen you can delete an element, and I've shown you 3 methods of how you can delete an element. The first one I've shown you the pop function. The second one I've shown you the remove function. The third one I've shown you the clear function, and the fourth one I've shown you the delete function. Then also the mutability has been shown, where you can remove elements, where you can not remove, where you can add an element. And I've taught you 2 ways which you can add an element. You can either use insert, or you can use append, and also you can replace. So that shows a list is mutable. The last example that shows a list is mutable, you can produce duplicate. You can produce duplicate. And how do you produce a duplicate in Python programming? For example, you have a list like this, which is 2, -3, 0, 4, and -1. And I want to produce a duplicate of this list. I'll say lst.copy. lst.copy, and when I run this, it gives me 2, 3, 0, 4, and -1. And when I try to produce a duplicate, it gives me the duplicates. So those 3, if you are asked characteristics of a list, the first one, it is ordered. The second one, it is mutable. Then the third one, it has duplicates. And when you are asked to show a list is mutable, I've shown you how you can replace elements. I've shown you how you can add elements, and I've shown you how you can now delete elements from a list. Further executions of list. For example, you have been given a certain list, and now you want to count the number of uh, some elements, the number of elements in that list. How will you do it in Python, the Python programming? For example, you have been given a list 2, -3, -3, -3, -3, 0, 4, -1. And you want to count how many times does -3 appears in that list. You will use the count function. You will say lst.count, then you put that element which you want to count its frequency within the list. So when you will run, it will give you an output 4. That means now -3 appears 4 times. Then you can index a list. You can index a list. This is where now you are, if you are, for example, you have been given this list. The list name is level. It has 4 elements. It has 5 elements. This means it has index 0 to 4. So when you will put any index in between 0 to 4, the list will give out that element. For example, here, if I decide I put index 0 and I run, I say Levi is the name of my list, and I want to know which element is contained in index 0. When I will run, you see it has given me 2. But now, in this second case, you see it has got from index 0 up to 4. But when I try to I want to get the list in index 5. I want to get the list in index 5. And you see it contains only from index 0 up to 4. When I will put 5, it will give me an error. What does this error suggest? This suggests that you are trying to reference an index which is not in that list, because this list only contains from index 0 up to index 4. The other thing is for you to know how to do how to reverse a list. Is for you to know how to reverse a list. And I will expect you just to know this method in cell 46 and cell 48. How will you reverse a list? For example, you have been given a list such as 2, -3, 0, 4, and -1, and you want to write this list in a reversed order. You will use a Python inbuilt function known as reverse. So you'll say lst.reverse, and it will write this list in a reversed order. When I will run, it will, you see, it has given me an output of this list now in a reversed order. You can do the same thing by applying now function definition. You can do the same thing by applying function definition. If you just choose either between the two, which one suits you. So this method in cell 47 is where now you apply function definition, and it will give you the same results. So you'll just choose. But I think in cell 14, this one is easier as compared to the one in cell 15. Then you can do you can do reversal of the list by applying looping. How will you apply looping? For example, I will call my my list item. So I'll say for item in reversed, because I want this list to be reversed. For item in reversed, uh, what I wanted to be reversed is 2, -3, 0, 4, and -1. Or yeah, I said for item in reverse, then I put the numbers in my list. Then I want it to be to print item. So here I've used the loop, and in my loop I've defined my items now is my list. Then in reversed, this is a reversed function when you use loop. So when I run this cell, you see now it has now these numbers has been reversed. It has now started by -1, 4, 0, 3, and 2. The other thing is when you want to sort a list. And when you want to sort a list, we normally use an inbuilt sort function, which will arrange the list, which will arrange the elements within a list in ascending order. So for example, I have my list there, and I want to sort them. I'll use list.sort, and it will arrange the elements within this list in ascending order. This means it will start from the smallest to the largest. Now, we have learned what is a list, and we have learned the characteristics of a list. The first characteristics I've told you, it is ordered. The second, it is mutable, and I've shown you different examples to show mutability. And the last characteristic is it has duplicates, and I've shown you that duplicate. So when you are learning about list, it is pretty good also to know uh, uh, to go into tuples, sets, and dictionaries, because although it was not covered in this chapter, but it is good because an examiner will assume that because you have covered list, you might be knowing the difference between a list, a tuple, a set, and a dictionary. That is why now I will show you some small thing about a tuple. Now we saw that a list is ordered, but now when we go to tuple, a tuple also is ordered. You have to know that. A list is ordered, a tuple also is ordered. A list is mutable, that means it is changeable, but a tuple is immutable, that means it is unchangeable. We saw a list has got duplicates, but a tuple has got no duplicates, and we will see in the examples below. Now, the other thing, we saw that a list is represented by a squared bracket, but a tuple is represented by a normal bracket. This just normal bracket. So, for example, when I'm writing this, when you are writing a tuple, this is my tuple. You see here, I have tuple is equals to 2, -3, 0, 4, and -1. You see the bracket which I've used here, it is the normal bracket. It is not the squared bracket. Whenever I will change it to this bracket, it becomes a list. Whenever I change it to this bracket, it becomes a list. And when it becomes a list, in a list you can replace. You can replace an element. For example, here, when I change it and I want it becomes a list, and I want to replace an element in index 0, which is 2, with 8. When I will run, it will replace. That means it is a list. But now, see, I want you now to be keen here. When it is a tuple, I have told you that a tuple is immutable. That means you cannot replace anything in a tuple, or you cannot add anything in a tuple. So when I change it to this normal bracket and I try to replace an element in index 0 with 8, when I will run, it will give me an error. And this error is a type error. That means you cannot do replacement in a tuple since it is immutable. Then the second example is you cannot delete an element in a tuple. You cannot delete an element in a tuple. For example, this is the case. When I will change this bracket like this, and it becomes a list, it will allow deletion. It will allow deletion. When I will delete it, it will delete. But now, when I change it to a tuple, I write it using normal bracket. When I change it to a tuple, it will not allow deletion because now a tuple is immutable. When I try to run a deletion in a tuple, it will give me an error. So that is the difference between now a list and a tuple. A list is mutable, a tuple is immutable. That means you cannot change anything. The other thing, now I want now to show you the similarity between a list and a tuple. In a list, you can do indexing. You can do indexing. And also in a tuple, you can do indexing. For example, I have my tuple, which contains those elements, and I want to know which element is in index 0. When I will run, it will tell me the element in index 0 is 2. The element is in index 0 is 2. Last but not least, under tuple, I told you that in a list, it has duplicates. But now, in a tuple, it doesn't have duplicate. For example, here, I want now, this is my tuple above here. I want now to get its copy. When I will try to run, it will give me an error, and it will tell me a tuple object has no attribute copy. That means you can't duplicate elements within a tuple, but you can duplicate elements within a list. The other thing now, you have known now the similarity and differences between a list and a tuple. The other thing is a set. Now, you have learned that a list, first characteristic of a list, it is ordered, mutable, and it has duplicates. Then characteristic of a tuple, it is ordered, immutable, and it has got no duplicates. So when you come to set now it is unordered. It is unordered. Then the second characteristic, you can remove or add element. Then the third characteristic, it has duplicates. So, then the second thing you need to know about a set is represented using a curly bracket. A set is represented using a curly bracket. I think you know what is a curly bracket. So I've told you that now you can add or remove elements in a list, in a set. Now, for example, in my set here, when I write this set, I will write S representing my set is equals to. Then you see now the bracket which I've used, it is curly bracket. Then I want my set to have 12, banana, and 5.3. When I run it, it will give me my my set. It has got 12, 5.3, and banana. It just comes from set theory in algebra. This is the same way we used to write sets in the university algebra. It just comes from the set theory. Now, I've told you that you can add or remove element in a set. Now, this set which has got 12, 5.3, and banana, I want to add an element, and that element which I want to add, it is Levi. So I'll take my set's name, which is S dot add. Then I will write Levi. Now, when I run this set, you will see now for the second time it has 12, 5.3, Levi, and banana. Now, as I've taught you earlier, that you can add or remove element in a set. Now I want to remove the name banana in this set. I'll just say s.remove, and then I specify the name which I want it to be removed. And when I will run, you will see this set now. It doesn't have the name banana. Then here I want to update. I want to update my set to have the name Joe, Mango, and Orange. When I will run, you will see now it has updated those names. Then the other characteristics which I told you is that a set has got duplicates. And for sure, you see this set containing 12 banana and 5.3. When I run it and I try to find the duplicate, and as I told you earlier, duplicate in Python programming, we find it using s.copy. When I run, it will give me the duplicate of this set. Then the other thing is dictionary. From the layman's language, dictionary just is used to give the explanation of some vocabularies. So also in Python programming, dictionary is used just to give explanation of some variables. And it is also represented by a curly bracket. For example, I want to make my dictionary, which is D. And also characteristic of a dictionary, it is unordered, it is mutable, and it has duplicates. I am making my dictionary, which I want the name val to be represented by 12 and name to be represented by ban. So after I've made this dictionary, you will see it will tell me val has been represented by 12 and name has been represented by ban. Now, I've told you that as a dictionary is mutable. So that means you can add or remove. You can replace elements. You can do those all operation. For example, I want to now in my dictionary, which contains val, and I told you earlier, val was representing a number 12. So I want this val no, I told you earlier that val was being represented by a number 12. So in this case, I want val to be represented by my name, Levi. So when I'll run, you will see this dictionary right here. The output has got now val, Levi, name, and ban. It is different from this one which had val, 12, name, and ban. That means dictionary is mutable. You can change elements within a dictionary. Then other characteristic is that a dictionary has got duplicate. For example, now I want to produce a duplicate of this dictionary. I'll just come here and say d.copy. And you see when I run, it will produce a duplicate of that dictionary. Then you, as you can also see, in dictionaries, you can delete an element. For example, I want to make a dictionary. Here, I want to make a dictionary where name is Zishan, age is 12, books we have the maths and physics one, then 100 is being represented by 3. Then I want to print the name, my dictionary to show the name and show age to show books. So when I will tell it to print name, it will show me Zishan because name is being represented by Zishan. When I tell it to print age, it will show me 22. When I tell it to print books, it will show me the books we have. It is for maths and physics. When I tell it to print books, and here I specify the index 0. And under the list of books, index 0 is maths. Because this is 0, then 1. It will print for me math book. And when I tell it to print the students, then book 1, that means now I want a book which is in index 1 under books list. So it will print for me physics. And when I tell it to print now a student and I reference it to 100, it will print for me 3. So when I run, that is the output that you are seeing below there. As I told you earlier, that a list is mutable, and we have seen you can replace an element. Also, you can delete an element within a list. You can delete an element within a list. When you want only a list to delete only one element, you use the delete function. So you will say del, then our dictionary name is student. We want from this dictionary the name to be deleted. So it will delete, you won't see Zishan. So that is where now when you use delete, it will delete the name. If you want it to delete maybe yeah, books, you just come here and say delete books, and you won't see books. Just come here and say delete books, and when you run, you have seen now it has deleted books in that order. That means a list is it is mutable. The other thing is where now you want to clear everything from that list. You use clear function, the same way we used in, I think, yeah, the same way we used in sets and lists. You use clear function. Clear function, it will delete everything. Further on lists, yeah, I think this one we passed it through, yeah, last week. Passed through that one. Now, the other thing which I want to show you is that a list contains it contains integers, it contains floats, it contains functions, and everything. So it doesn't only carry character values, because when you are constructing a string, we saw that a string has got only characters, but a list has got a combination of characters, integers, functions, function, and what have you. So for example, in this example, you see we have got a mixture here. 24.2 is a float, 4 is an integer, word is a string, eval is a function. You remember when you are covering eval function. 19 is an integer, negative 0.03 is a negative number, and end is a function. So what you need to know about a list, it can carry anything between a character, integer, float, function, and what have you. So this is just an example to show that a list can carry all those things. And now, for example, you have a list, your list here, and you want it to be written in a looping form. So the name of your list is collection. So if you want it to be written in a looping form, you say for values in collection. And I have told you once and again, when you are looping, it has to end with a full colon, because here we have said for values in collection, full colon, print values. It will print for you all those values. The second thing is where now when you want to determine the number of elements that a list contains. When you want to determine the number of elements a list contains, we normally use an inbuilt len function. What is this len function? This len function, it is just a function that means length in Python programming. So for example, here you see we have got how many elements? 1, 2, 3, 4, 5, 6, 7. So when you want to know the number of elements within a list, you normally use inbuilt len function. So for example, this means here, this first list has got 7 elements, and the second list, which you have called it A, has got 5 elements. If I can show it clearly, for example, I have a list here named X, which has got those numbers. And I want to get now how many elements are contained in this list known as X. How will I do it? I'll just write len X. And when I run, it will give me all the elements within this list. Now, the other example uh, is where now you want to write a list starting from index 0 to the last element, where you want to write a list starting from 0 to the last element. This code just represents a looping form which you can write a list starting from 0 to the last element. Now, the second one just represent writing a list now starting from using now the negative indices, using the negative indices. This means you will start from a -1 up to 0 element. And below there, I will show you in detail how to deal with these negative indices. Now, you remember when you are doing strings in our earlier chapter, I told you that strings can be concatenated. The same way a string can be concatenated, it is the same way now a list can be concatenated. Concatenation just means merging together two lists. For example, I have a list here named A, and it has got those elements. Then I want to merge this list A with another list, and I call it X. So I'll just say A plus this, I will use an addition sign. So this means a list is merged or concatenated using addition sign. So when I will run, you will see the first list known as A, it will be concatenated with the list which is 1, 3, 5, 6, 8, and 9. And it will give me now the value, the new values, elements within a list known as X. The same way we can concatenate a list. Also, tuples can be concatenated with an addition sign. You see here I have a tuple 2, 4, 6, and 8, and I have called that tuple Y, and now I concatenate it with another tuple which is 1, 3, 5, 6, 8, and 9, and I call that tuple X, and you see it has been concatenated. I think up to that you have gotten me correct. Now, the other thing which you need to know is that a list can only be concatenated with another list. A list can only be concatenated with another list. You cannot merge a list with a set, a tuple, or a dictionary. When you will merge a list with either a tuple, set, or a dictionary, it will throw an error. For example, here, I have a list which is X. I want in this list to add another list which is A. And you know the value of A is 2, 4, 6, and 8. I want this to be added, and then list A to be added to 1, 3, and 5. When I run this list, you will see it will concatenate. It will concatenate when I run it for the first time. It will concatenate 2, 4, 6, 8 with 1, 3, and 5. Then you see I've written A plus is equals to 10. I've written just a single list. So when I run it for the first time, this 10 will not appear. But when I run it for the second time, it means before I concatenate 2, 4, 6, and 8, and 1, 3, 5, that 10 will appear at the midst. So just look, when I run it again, you see that 10 has appeared here. It has concatenated 2, 4, 6, and 8, and 1, 3, 5, and 10 has appeared here. When I run it again, that 10 will appear for the second time. Again, it will keep on appearing. So what I want you to know is that a list can be concatenated with another list, but a list cannot be concatenated with a tuple, a set, or a dictionary. For example, this is a good example here. I want to concatenate a tuple Y. You saw here this Y was a tuple. Y was a tuple because I had written it using a normal bracket. So I cannot concatenate it with a list. When you will try that, it will throw an error. So a list is only concatenated with a list. And also you see here, I was trying to concatenate a list with a set, and it threw an error. That means a list can only be concatenated to a list. Yeah, and also in this instance, I'm trying to concatenate now a list with a list, and I wanted to have an increment of 20, and I've not specified it to be a list. I've just written 20 without those squared bracket, and it gave me an error because it will only accept a list to a list.
I have a question.
Yes,
When we say ordered and unordered,
yes.
what exactly uh, does it mean?
Ordered and unordered.
Yeah,
Yeah, in ordered, you see we have written, for example, when you are writing a list and a tuple, you have written it in a comma separated form. But now you see when you are writing, for example, and uh, yeah, in a comma separated form. And now you see when you are writing something like a set, something like a set. We wrote, for example, Levi, then banana, then 12.5. So you see, uh, when you are writing a list or a tuple, it shows some orderliness. But now, when you come to write, for example, a dictionary and a set, and this example comes clearly when you are writing a dictionary. A dictionary, you are writing Amos. Amos represents 12. Then you come and write Levi represents what? Let me go there so that you can see it clearly. There is something I want to explain here. Let me see. Now, I must look here. For example, when you are writing now this as our set 12, banana, and 5.3, at first it gave us an output of 12, 5.3, and banana, isn't it?
yes,
Now, when I tried to add a new element, I said add. I said add Levi. When I added Levi, you see now the output, it will become 12, 5.3. And in this first output, it was 12, 5.3 and banana. But here now it is 12, 5.3 Levi, then banana. That means it is unordered. As compared to a list, you saw the same argument which you can use in a list. It is append when you want to add an element. When if it was a list, if I could have added levy, this levy will come at the it will
at
come
the end.
at the end of that set. But
Yeah.
now you see levy has come now, I think at the midis. So that means it is unordered.
Okay.
Yeah. And now the list also can be written in form of a loop. There is a way where you can write a list in form of a loop, and in conjunction with the definition of function. For example, I want to write a number of lists here. I want definitions. So I'm defining my main, and my first list, I want it to be ranging from 0 to 9. When you put 0 to 10, I've taught you that it will count from 0 to 9. Then my second list, I want it to be counted all the way from 9 up to 0. From 9 up to 0. You see this -1, it means that it is the same as index 0. It is the same as index 0. That is negative indexing. So when you see this 10 here, it means it will run from 9 all the way up to 0. Then I want to create a list 0 to 100. If I could not have put this 10 here, it will run from 0 up to 99. But now, what is the meaning of this 10 here? I want it to be having the difference of 10, 10. So it will run up to 90. So it will not go up to 99. Then in this case, I want to create a list from -5 to 6. That means it will print the numbers from -5 up to 5. As I told you earlier, it normally assumes the last number. And since I defined my list, I have to end it by also defining. I have to end it by also defining. So when I do that and I run, it will produce for me all those lists. It will produce for me all those lists. That shows that a list can be written using functions definitions. A list can be written using function definition in together with loops. The other thing you need to know is that a list can be multiplied. A list can be multiplied. And look here, and you will see how a list can be multiplied. For example, I say define main. So I want my list to be under definitions. Then my first list is 1, 2, and 3. I want to multiply it by 5. This means this 1, 2, 3, it will appear 5 times. 1, 2, 3 for the first time, 1, 2, 3 for the second time, until the 5th time. Then I have my list only having 3.4. I multiply it by 5. It also means it will appear, this 3.4 will appear 5 times. And you can put multiplication either to the right or left. It won't affect anything. It won't affect anything. So in this third case, I have my list. And as I told you earlier, list can handle anything, be it a string, be it a function, integers, or what. So in this case, it is a list containing string, and I want to multiply it by 3. That means ABC will appear 3 times. ABC for the first time, ABC for the second time, ABC for the then I have a list here having 10, 20, and 30. I want to multiply it by 4. It means this 10, 20, and 30 will appear 4 times. And then because I had started by defining it, calling my list to be main, I'll have to end with the main, so that when I run it, it will show me now list multiplication. And as you can see, a list can be multiplied. The other thing is list equivalence, assignment and equivalence. What is list equivalence, assignment and equivalence? This is where, as a programmer, you need to know the list which are equal and the list which are not equal. This is now where we will apply equality sign. This is where we will apply equality sign. And this is where I will expect you people not to confuse the difference between equality sign and equality operator. When you want to show two variables are equal, we normally use equality sign. And the equality sign is where now you write the equal sign twice. Equality sign is represented in Python where you write equal sign twice. And assignment operator, you just write equal sign once. For example, when I write A is equals to 10, 20, this is equals to is an assignment operator. But when I want to say A is equals to B, to show, to distinguish equality, I'll say A is equals to B. Now, these are examples that will help us to come up with equality equivalence, assignment and equivalence. We'll start by assignment. We normally assign a list the normal way we assign other variables in Python programming, and that one you have seen. For example, here I have a list 10, 20, 30 to 40. Then B is 10, 20, 30 to 40. Now, this print is just to display my list where I want to display A and I want to display B. Now, I want to replace index 2 in list B with 35. And my index 2 here is 0, 1, 2 is 30. This 30, I want to replace it with 35. This is how you do replacement. This is how you do replacement, as the list is mutable. So it means it can allow replacement. Then after I have replaced, I want it to be displayed. So I will run. When I run, you see the first A and B, it is 10, 20, 30, and 40. But the second A and B, you see it is 10, 20, 30, 40. But for B, it is 10, 20, 35, and 40. That means now the element in index 2, which was 30, has been replaced by 35. You can now do the same. You can now do the same. Instead of here you saw that we had written 10, 20, 30, and 40. In the first case, in the first case, you saw that we had written 10, 20, 30, and 40. Then B was 10, 20, 30, and 40. But you can avoid to do that twice. You can avoid to do that twice if now you want to show these two lists are equivalent. You can avoid to do that twice. For example, if A is equivalent to B, you will just write the elements for A alone. When it comes to B, you'll just say B is equals to A. You just say B is equals to A. And when you will print A, it will give you the elements in list A. And then when you will print B, it will give you the same element which was in list A, because here you have specified B is equals to A. That shows equivalence, or they are equivalent. Then I want to do the same thing of replacing our an element in index 2 with 35. I'll just do the same thing. And when I run, it will just give me the same results as what it gave me in the first case. So in this one, how I've written this, it shows that B is equivalent to A. And when they are equivalent, you don't need to write A 10, 20, 30, and 40, then B 10, 20, 30, and 40. When you have written for one, that is okay. For the second one, you'll just say B is equals to A, because it will show equivalence.
I have a question.
Yes.
When you do the print, there
Yes.
is the way you enter the variables, that is A.
Yes.
I'm seeing there is A in quotation marks, and then there is a sorry, what is that? Equal sign.
Okay.
And then there is another, there's a comma. Why can't we just do A in quotation marks?
No, you can't do A in quotation marks alone. Now, I want you to get this. Let me write that A.
Oh no,
Amos.
I'm saying if we just do A in brackets, sorry.
Yeah, I'm getting you. I'm getting you.
Yeah.
You are going to get the difference. When I write that, you see, I've changed it to Amos, isn't it?
Yes.
Yeah, it will tell me the value representing Amos is 10, 20, 30, and 40. Now, you want me to write this way. You're going to get it clearly. This is what Amos you want me to write it. Let me copy paste here. I've understood what you are saying. and I put it here.
Yes.
Now I want you to check the difference and you'll tell me. Now check the difference. Are you seeing the difference?
Yeah. Okay. I'm seeing.
Yes.
Oh, now the definitions of the variables are not included.
Yeah. So this first A, which is inside the quotation mark, it is just the definition to tell you A it is equals to a certain number, B is equals to a certain number. That is it.
Okay.
Yes.
Is that this?
Yes.
Yeah, I see there's a difference.
Yes.
Okay.
Yeah. So
But the elements remain the same. It's only the
yeah, the elements remain the same.
okay, it's only the definition that is left out now.
Yeah, it is only the definition that is left out.
Okay.
Yes. Now the other example now is where now maybe you want to show two lists are equivalent or they're aliases to each other. How will you do it in Python programming? When you want to show two elements are equivalent or aliases to each other, how will you do it in Python programming? For example, I have my list here, which is A and B. This first case, I've written A is equals to 10, 20, 30, and 40. And for the second case, I've written B is equals to 10, 20, 30, and 40. I want to show equality of these two lists. How will what will I use to show the equality? To show the equality in Python programming, you use double equal sign. You use double equal sign. That is why here you see I'm saying print A is equals to B. Print A is equals to B. I want to see if they are equal or not. And to show the equality, it normally answers a true or false question. If they are equal, it will say true. If they are not equal, it will say false. And in this case, you see A and B, they are equal. So you will expect it to answer true. Now that one has answered the equality. That one has answered the equality. What if now you want to answer the aliases? The equality is represented by A is equals to B, but aliases is represented by A is B. A is B. When you want to show aliases, you'll say A is B. When you want to show equality, you'll say A is equals to B. So in this case, it will be true. But in this case where you want to show aliases, is A is B. In this case, A is not B. Why? If it could have been A is B, uh, here you will not write again B is equals to 10, 20, 30, and 40. You will just write B is equals to A. That means they are aliases to each other. But when you write B is equals to 10, 20, 30, and 40, they are not aliases to each other. So B is not A or A is not B. So in the first case, A is equals to B, it will give us true. In the second case, where we are testing aliases, it will give us false. Now, you have been given now two numbers again. In this case here, it is C and D. C, we have been given it is 100, 200, 300, and 400. Then D, you have been given D is equals to C. Then the first thing, they want you to test for equality. For equality, C will be equal to D. That is true. And for aliases, C is D, because C will be D. That is true, because in this case here, we have written D is equals to C. We have not written the list again. If you could have written the list again, that means they will not be aliases to each other. But since we have not written the list again, it means D is alias to C. So when I will run, for the first case, A is equals to B, that is true. For the second case, A is aliased to B, that is false. For the third case, D is equals to C, that is true. And D is alias to C, that is true. List bounds. So we are going to touch on list bounds. We know what is a list bound. Now, a list bound, a list has got a boundary. It has got a boundary. When you go beyond that boundary, or when you go beyond that boundary, it will give you an index error. It will give you an index error. Why will it give you an index error? Because now you are specified an index which is not within the list. For example, this list has got how many index? 0, 1, 2, 3. If I will put here 0, it won't throw an error. It won't throw an error because 0 is in the list and the value representing 0 is 10. But now, look here, when I put index 4, this list has got only 0 up to the third index. So it will throw an error. That means that index is out of bounds. That list is out of bounds. So when I will try what am I saying? That index is out of bounds. So when I will try to enter an index which is out of bounds in list, a list will throw an error. So you have, when dealing with the list, you only have to give your list an index which is in bound. So anything that is out of bound, it will throw an error. It will throw an error. Then now, this one here, it just talks about negative indexing. Just talks about negative indexing. What we have covered up to this juncture, it was all positive indices. But now also you can apply negative indices. For example, I have my my data here defined under main. This data is 10, 20, 30, 40, 50, and 60. When it is positive index, this 10 is 0, then 1, 2, 3, 4, 5. But when it is negative index, I will start counting from where 60 is. I'll start counting from negative 1, negative 2, 3, 4, 5, 6. That means now I want to get the elements starting from 60 downwards. So this is just negative indexing. The other thing now is about slicing. And I think this one we covered in detail last week. I don't know if I can repeat again or just bypass it. Amos, are you comfortable here with this slicing?
Yeah, slicing, I think I am. What I didn't get is alliances. That's what I didn't. I'm sorry to take you back.
Okay, what I can say about aliases, let me go back.
But,
Now, Amos, when we say equality, you see here I've written 10, 20 up to 40. Then I've written again B, 10, 20 up to 40, isn't it?
yes.
When you write the same list twice, that means they are not aliasing to each other. Are you getting me?
Okay.
But now here, you see I have written C is equals to 100, 200, 300, and 400, isn't it?
Yeah.
And when I want to write D, I've just written D is equals to C. I've not written again D is equals to 100, 200, 300, and 400, isn't it? So when I've not repeated, I've just said D is equals to C. That means now D and C are aliasing to each other.
Okay. I get it.
Yes. So that list slicing, we did it in detail the last week, and I don't think if there is need for us to pass through it again. Yeah.
So I have a question.
Yes.
When do you use a list, and understand tuples is not used so much? Is it used only when you want to like protect the data, or when do you use lists and tuples? And also
Yeah. Yeah. For example, when you are using a tuple, that is when now you want. Uh, it is normally used a lot by people in cybersecurity.
oh,
Yeah, when you don't want any other person to interfere with the elements which you have written, you don't want it to be deleted, to be modified. That is when now you use tuples.
okay, that's what I thought.
Yeah. So that is it, Amos. That is the end now of this chapter.
Oh,
That
thank
is, yeah, that is the end. And I will not teach chapter 10. What I realized, I combined chapter 9 and 10 because they were somehow similar. And also, it took some concept from chapter 11. So, this means that we are only remaining with only one class.
you. Oh, and it will be done with Python.
Yeah, we will be done with Python. And that remaining one class, it will not take even more than an hour. It will be just a 45 minutes class.
And then we shall be able to code.
Yeah, you should. Right now, you are coding. I hope right now you are coding.
Wow.
Okay, so the thing which I want to show you right now, I want to give you people the last project. Are you getting me?
Yeah.
Yeah, I want to give you people the last project, and this project it will be related to what we have just covered, but it will be now in a practical overview. This is the project, please. I did with these people yesterday. Let me look at it, please. Now, I think everyone, let me see, everybody is viewing my screen. So this is the project. This is our final project in this course. And then after next week, I think now you'll be full prepared for the certification. Now, what I will expect from you, I will expect you people to do a project. I will send it to you, the question for the project. I want to know if you can apply the knowledge of list in real life situation and in data analysis. Now, in this project, it is just a small analysis. It is just like an high school mathematics in that form formats in statistics, where a teacher gives students a range of some numbers. He wants them to compute standard deviation, variance, range, and what have you. And maybe to come up with a visualization. They are normally asked to plot an histogram, isn't it? I think Ruth can bear me witness. They are normally asked to plot an histogram. So you have to import some packages in Python. The first package which we normally import is NumPy, because NumPy is numerical Python. It's just all numerical computation in Python programming. Then the second package we will import is matplotlib as plt.pyplot as plt. This will help us in plotting. Then the last package which we'll import is Seaborn as CNS. This will give us, it will enable a programmer to have some styling in his visualization, his or her visualization. When you want to add colors, when you want to add some effects, that's where we use Seaborn. Now, I don't know if Ruth, you can unmute. I ask you something.
I did.
Okay, Ruth, if you can see my screen, we want to create a list, and this list, we want to call it a data frame. And because you are a teacher and you are the people who normally gives this student those numbers for them to compute mean, standard deviation, I want you to give me some numbers so that we can use. I don't want to use this one, which is here.
Like I just give you any numbers?
Yeah, just give me any numbers. We want to use the number which comes now from the audience.
Okay. I'll start with 10.
Let me now delete these ones. Yeah, you'll start with 10.
Can the numbers be floats also? Like, can I just give a mix of
Yeah,
floats?
you can give even a float.
Okay. 15.1.
15.1.
17.2. How many
17.
numbers do you need?
Let us, I'll just tell you.
20.
Well, 20.
24.5.
24.5.
26.
26.
31.
31.
43.
43.
45.2.
45.2.
51.
Yeah, 51.
55.
Yeah, give me some larger ones.
150.
150.
200.5.
200.5.
600.
600. Yeah, let us, that is enough.
Okay.
So you see, I've made my list. Everyone can see I've made my list, isn't it? So when I will run, You see it has given me all the numbers which Ruth has given me. Now, because just assume these are the numbers which a maths teacher or a statistics teacher has given his or her student to compute mean, standard deviation, and what have you. So we want to start computing mean. We want to get the mean of these numbers. So how will we get the mean or average? We have named our data, this list, we have named it to be df. So for us to compute the mean, we'll say df.mean. So when I run this df.mean, you see it is giving us an error. And Amos, can you read this error?
Error is list object has no attribute mean.
Yeah, has no attribute mean. Why are we getting such? We are getting such because now you have just constructed a list. But this list, for it to be computed, those statistical measures such as mean, standard deviation, has to be a number array list. Has to be a number array list. How do you make a number array list? This is how you make it. You see in this cell 5, I'm now making a number array. I'm saying df is equals to np. And you remember here I said import np as import number as np. So that means now I'm making a number array. So I'll say df, which is the name of my list, np.array. np.array. Then I will enter all those numbers. I put the normal bracket, then the list bracket. Then I entered all those numbers. So I'll, because those numbers were already there, I'll just come and copy what Ruth has given us up to this point, this way, and just come and paste it here. And I paste it here. So when I will run, then I will run this. You see now it has given me all those numbers which Ruth has given us in a number array form. In a number array form. So because now it is in a number array form, we can now compute mean, standard deviation, variance, maximum value, and what have you. So let us start by computing mean. For us to compute mean, we just write df.mean. When we write df.mean and we run, it will give us the mean of those numbers is 92.035. When we want to get standard deviation, we just write df.std, and then you open and close the bracket. When you run, it will give us the standard deviation. When you want to get the variance, you just say df.var. When I run, it will give me the variance. When I want to get the maximum value, you just say df.max, df.max, and when I run, it will give me the maximum value in this list is 600. The maximum value in this list is 600. Then when I want to get the minimum value, I just say df.mean. Then say df.mean. It will give me the minimum value in this number list array is 10. When I want to get the range between now the smallest and the largest number, I'll say df.ptp. PTP in Python, it just stands for range. So when I will run, it will give me the range is 590. What if now I want to get the length? The length in that list is for me looking at how many elements does this does this list contain? I'll just say len this way, len, and I put the bracket and I say df. I want to get the length of df. It will just count for me the number of elements that the list contains. When I will run, it will give me 14. It means our list has got 14 elements. Now, after that, I want to plot an histogram. I'll say plt.figure in bracket. Then I want my figure to have a dimension, the size of 10, that is the length, and 5, that is the width. Then I want to plot an histoplot. So I'll say histoplot, sns.histoplot. This is Seaborn, sns.histoplot. Then I want to plot an histoplot with my data frame, and the name of my data is df. Then, because I've told you that when using Seaborn, it will enable you to have styling in your plot. So I can decide the color of my histoplot to be red, that way. Or I can, if you want it to be in default, when you will run, it will just be blue. That is the default color. It will just be blue, that way. If you want now to have a color, you just come here and you put a comma and write color is equals to red, that way, and it will give you the color for your visualization is red. And now that is how you can plot an histoplot. If you want to plot a box plot, you come and just replace hist with box. Just say come and replace hist with box this way, and it will draw for you a box plot. What if you want to plot a violin plot? You just replace again box with violin. This way, with violin. That way, it will draw for you a violin plot. Now, after that, you want maybe to find the z-scores. The z-scores. Z-scores in statistics, it is just the distance of a value from the mean. It is just the distance from the mean. That is z-score. How will you find the z-score? The first thing, you have to import scipy.stats as stats, because as I told you earlier, each and everything in Python programming has got its libraries. When you want to do things concerning engineering, it has got its library. Medicine, it has got its library, and what have you. So you come and say import scipy.stats as stats, and you run. Then you want to find the z-score of your data. Z-score of your data. You will say stats.z-score. Then the name of your data frame is df. So when you will run, it will give you all the points, the distance from the mean of all the data points. The distance from the mean of all the data points. Then, for example, you want to compute first quartile in the quartile range, then in the quartile range, then the one it is normally in Python programming. You want to compute the quantiles. This is how you do it. You just say numpy.quantile bracket df, then you enter the quantiles. You want to get the first quartile, the median, and the third quartile. So when you will run this code, it will give you from the first quartile the minimum value, first quartile, median, then third quartile, then maximum value. To compute a percentile, of maybe there's the 60th percentile. You just write that code, numpy.percentile, then df, 60. It will compute for you the 60th percentile, and it gives you, yeah, that is it. And what if maybe you want to compute the t-scores? Let me see if it will compute the t-score. No, this data, it can't compute the t-score. So that is all it takes for our project. So I'll send to you this notebook. That is the one you will use now for your project. So that is the end of our today's lesson. Let me send it right away.
Mark, I didn't receive your phone call.
Yeah, I forgot. I don't know when can I call you again.
Maybe you slept.
I forgot to call you.
We'll arrange, or maybe, let me see. Can we do it on Tuesday?
At what time?
What time is good for you? Like around, let's say around 10 o'clock our time. 10
10
p.m.
o'clock.
Yeah, 10 p.m. our time. That's daytime over there.
10 p.m. your time. I'll just subtract and I will get my time.
Yeah.
It is still the difference of 7 hours, or it is 8?
I think no,